we are going to learn about the vertex and intercepts, x and y intercepts of quadratic equations, but not any quadratic equations, just the quadratic equations or second degree equations that have two variables where only one variable has the power of 2. So you have seen already we have different types of quadratic equations. For example, this is 1, x squared plus y squared equals 1. This is quadratic equation because the greatest power of the unknown is 2. This is another one, x times y plus x squared equals 10. This is also a quadratic equation. And x times y plus x equals 1. This is also quadratic equations because we count the sum of the power of the unknown. So x to the 1, y to the 1, the sum of them is 2. So this is second degree equation or quadratic equation. But today we're going to only cover the vertex and intercepts of quadratic equations that have two variables, but only one variable is raised to the power of 2. Something like this: y equals x squared plus 2x plus 3. Something like this is going to be the type of equations that we are going to talk about. And they have a general form that we have been introduced to already, and that is y equals ax squared plus bx plus c. So we're going to talk about this type of quadratic equations and their graph. Their graph, the shape of this, when we graph it with two axes x and y, the graph is called parabola. The graph is called parabola. And the word parabola, what does it mean? It means it comes from Latin. It first comes from Greek and then has entered Latin and has entered English. It means juxtaposition or placing a figure near another figure in contact with another shape to see the contrast. So, and I will tell you why they call the graph of quadratic equations parabola. At the end of this video, we're gonna talk about that, why they call this parabola or juxtaposition. What's the correlation for this name? Okay, now let's get started. So you have seen already how we graph these kind of equations, and once again I'm going to write the general form here. Y equals a times x squared plus b times x plus c. Okay, plus c. Now, we already tried to figure or graph one equation like this before, and we did this by drawing a table. One side of the table, one column is x, one column is y, and then we figure out different points from this equation: x1, y1, x2, y2, and so on, until we put all these dots on the coordinates. We find the coordinates for this equation and we graph them on an x and y axis. And as we saw, they have a shape of like a U, something like this. Once you figure out all these points, then you can connect them all together and you'll see they look all equations that you can write them as this form, in this form, quadratic equations with two variables where only one variable has a power of 2, they all would come to this shape. And these sides, the legs or the hands, they just go on to infinity. Just continues. So, I want to ask you, are you able to predict the shape of this graph of the U based on by just looking at the equation? So we're going to learn how to predict a few aspects of these shapes by just looking at the equation. When the mouth of this U is upward, that means the A in the equation is positive. A is positive, and then the mouth is upward. If A is negative, then we're going to have a shape on this graph that the mouth is downward, something like this. So in these occasions, A is negative. So anytime you turn a quadratic equation into this general form, A, the value of A, whether A is positive or negative, determines the direction of the mouth of this shape. Upward, A positive, downward, A negative. Vertex is this tip of the graph here. This tip of this shape, or on this one, this tip here, sort of looks like a nipple, is the vertex. So this thing is called vertex. Okay. One more thing we can tell when we just look at whether A is positive or negative. We can already tell that if this shape has a minimum or has a maximum, because if the A is positive and the mouth is upward, the graph is just shooting up, right? From this side just going up, from this side is going up. The lowest point on this graph, the lowest value of Y on this graph, the minimum, is actually the vertex, right? So when A is positive, the vertex is the minimum. And on the other hand, when A is negative, the graph is just shooting down. It's just going down, down. So the highest value, the maximum, is the tip, the vertex. So when A is negative, the vertex is the maximum. Okay? There are other names associated with this shape when it's, for example, I say the mouth upward, but sometimes they call that, the mouth being upward, they call it convex. Or when the mouth is downward, they call it concave. Concave. What are these words? Concave, just like the name cave suggests, right? Cave is like a hole in a mountain. So concave means curve inward. So anytime you want to remember what concave means, just remember the cave. The cave has a hole in the mountain, so it's like curving inside, inward. That's concave. And the opposite is just convex, which means curve outward. Okay. Now, what else we can immediately tell by just looking at the equation of a quadratic equation? We can find out the x-intercepts, right? What are the x-intercepts? The x-intercept are the points where y is 0. Y is 0, meaning the shape of the graph is crossing the x-axis, because at these points that I'm going to now show them with blue, at these points, the x-intercept, these are the x-intercepts because the y at these points are 0. Now, we know already when y is 0, so basically we have to solve an equation that looks like this. Ax squared plus bx plus c equals 0. So we have seen already how to solve this kind of equation. This is a quadratic equation with one unknown. And the formula to solve this is, I'm going to write here, x equals minus b plus minus square root of b squared minus 4ac over 2 times a. So this is the formula by which you find the zeros of this equation. In other words, the x-intercepts of the parabola. You can try that with the equation. You can just write an equation for yourself and find out. And you can see, you already saw that some of the quadratic equations, they don't have a real solution. So now we're going to see what happens with the shape of them when there's no real solution. So imagine these 3 cases. Let's imagine 3 cases here. 3 shapes. So when there are 2 real solutions, when you get 2 real solutions, there are 2 x-intercepts. They look something like this. So this is 1 solution, 2 solution. Again, 1 solution, 2 solution. The zeros of the function, the x-intercepts, right? We know that some of the quadratic equations, they just have only 1 real answer or 1 x-intercept. So can you imagine how does the shape look like in those occasions? Yes, the vertex or the tip is just touches the x-axis only at 1 point. That's when you just have 1 real solution, or only one x-intercept. In another case, it could be just the mouth could be downward, but still the same case. It's just kissing. The tip is kissing the x-axis. They only meet at 1 point. That's it. So in this case, 2 real solutions. In other words, 2 x-intercepts. In this case, we have only 1 real solution or answer. In other words, 1 x-intercept. And sometimes there's no real solution to the equation. Can you imagine that? How does the shape look like? Yes, there's no contact with the x-axis. You see in this case? So the minimum, which the vertex is the minimum because the mouth is upward, the graph is just shooting up. So the lowest point or the minimum is here, and it never touches the x-axis. It's already above the x-axis. So in this case, there's no real solution. Also in this case, when the mouth is downward, but the vertex, which is the maximum, is lower than the x-axis. So in these cases, no real solution, or no x-intercept. Okay, so that's in terms of how the shape of the equation, the parabola, looks like for different cases. And we know when there are two real solutions, if you remember the quadratic formula, b squared minus 4a times c is positive, and this was the determinant, right? D. The determinant is positive, so you have two real solutions. Determinant is 0, you have one real solution, and determinant is negative, you have no real solution. So by looking at the general form of the quadratic equation, we can already have a good amount of knowledge about the shape of it. Okay? Now, let's see how can we tell the coordinates of the vertex for the quadratic equations. The coordinates of the minimum or the maximum of second degree equations. Let's find out how can we tell. So I'm going to write once again the general form, y equals ax squared plus bx plus plus c. Nice. So the vertex form, the coordinates of vertex, we need the x and the y of it, and they're separated by comma. Those are the coordinates. The coordinates of the vertex for quadratic equation is this. The x of it is minus b divided by 2a. And how do I know that? There's a method called derivative that is more advanced, and we're going to cover it too, that using that we can immediately tell the vertex. But for now you can just memorize it. And what would be the y of the vertex? Well, that's easy because we can just plug this in, plug the x in to the equation and find the y, right? We're going to do that later. For now, you can pause the video and do that. I'm going to write the final answer so you know if you did it correctly. So you should be able to, once you plug in x as negative b over 2a, you have to find something like c minus b squared divided by 4a, or a variation of this form. So that's the y of the vertex. Sometimes instead of giving the equation as the general form like this, they write the equation as vertex form. There is a vertex form for quadratic equations, and that makes it easy for immediately finding out the coordinates of the vertex. That form looks like this. Y equals a, the same a as we had over there in the general form, a times parenthesis x minus h, close the parenthesis, to the power of 2, the entire parenthesis to the power of 2, plus plus k. Okay. Now, when you have the equation in this vertex form, the coordinates of the vertex are the coordinates are, the x is h, comma, the y is k. That's it. So if the quadratic equation is written in vertex form, you immediately can tell the coordinates of the vertex. Now the question is, how do we convert a quadratic equation from general form to vertex form? And that is easy too, because now we know the h equals the x of the vertex is minus b divided by 2a. This 2 has to be white to follow the color code. So minus b over 2a, that's the h, and the k equals c minus a fraction, and that is b squared divided by 4a. Nice. So that means if you're given the general form of the quadratic equation, you can find h and k using these formulas. H equals minus b over 2a, k equals c minus b squared over 4a. And then use h and k and a to write the vertex form, which is y equals a times x minus h to the power of 2 plus k. So you can convert it. Now converting vice versa, how do we go from vertex form to general form? That's also very easy. Let's do that. So I'm going to write it here. Y equals a times x minus h to the power of 2 plus k. We want to go, now this is vertex form, we want to go from vertex form to general form. This is how we do it. We're going to expand this equation. So we have a times, a is multiplied by x minus h to the power of 2. So that's x minus h multiplied by itself times x minus h, because that's the meaning of power of 2, right? And then at the end is just added k to it. Nice. Let's just deal with this for now, and then we substitute it in there. X minus h times x minus h. What does that mean? How do we have to solve it? That means one time x gets multiplied by x, and one time x gets multiplied by a negative h, right? Negative h. And then another time negative h gets multiplied by x, and also another time negative h gets multiplied by negative h. So let's do that step by step. X, the blue stuff. X gets multiplied by x, that's x squared. X multiplied by minus h, that's minus hx. This is squared. Now the red stuff, the red arrows. Minus h multiplied by x, that's minus hx. Minus h multiplied by minus h, that's positive h squared. Now we're going to combine terms. Again, we have learned how to do that. So we have two terms of the same nature here. One is this guy, one is this guy, because they both have a number, like an h, because h really represents a number. X is the unknown, and it's to the power of 1, so they have the same nature. So I can rewrite this as x squared minus hx, that's minus 2hx, plus h squared. Okay, now so that's the result of this parenthesis, PEMDAS, right? First we dealt with parenthesis, and parenthesis had an exponent, so we multiply them by each other. So now let's plug that in. So we get a multiplied by parenthesis, inside parenthesis, x squared minus 2hx plus h squared, close the parenthesis, plus k. Okay, so what does that mean now? That means we have to distribute a into this parenthesis, because a gets multiplied by the entire parenthesis. So one time gets multiplied by this, and by this. Let's do that. Equals a x squared minus 2ahx plus a h squared, and at the end plus k, which is outside. Nice. Now what do we have here? We have ax squared. So I'm going to write the general form here so we can compare them together. So the general form of, and of course this is y equals that, right? Y equals this, always. The general form was this: y equals a x squared plus bx plus c. So now we compare them and we see what's what. A is exactly the same. A is A. So if I write them, the A in them is the same, similar. They share the A, both of them. The B in them, B is what is multiplied by unknown to the power of 1, x to the power of 1. So B here is this entire thing, isn't it? So I can write B equals minus 2a times h, and C equals, C is the lone number, there's no unknown, neither x nor y. So C is this entire thing. C equals a h squared plus k. Nice. So we learned how to go from vertex form to general form. You can just, so A is the same, so you know already A when you look at the vertex form. You can find out the B, which is equal to minus 2 times A times H, and C is AH squared plus K. So you find A, B, C, and that's all you need to find out the general form. Excellent. So we learn how to go from general form to vertex form, and from vertex form to general form. And the coordinates of the vertex, once again, is H and K. Easy peasy. If A is positive, you have A is positive, so the mouth is upward. Let me actually summarize that. So when A is positive, the mouth of the shape is upward, so you have the vertex is a minimum for this equation, the lowest point. And when a is negative, the mouth of the shape is downward and the vertex is a maximum. So we talked about the vertex, we talked about x-intercept. How about the y-intercept? What is the y-intercept for a quadratic equation for parabola? We know that it's where the equation, the graph, the line, the curve of the equation crosses the y-axis. So over here, for example, in this shape, or over here in the case of this one. Y-intercept is kind of the easiest thing to find out because you just replace x with 0. X is 0 at y-intercept, and you find the y. So if, for example, in the general form of the equation, if we do that, let's see what we get. Ax squared plus bx plus c. If I substitute x as 0, this term is going to cancel as 0. This term is going to get canceled at 0. So y equals c. That's it. So when x is 0, y is c. That means the y-intercept is this point here. The y-intercept, x as 0, comma, y as c. That's it. As easy as that. Now, let's talk about why we call quadratic equation, why we call its graph parabola. And that's because, and we said parabola means juxtaposition, means a shape is situated near another shape. So another definition for parabola, or the graph of the quadratic equation, another way of describing it is that all the points that are located at a similar distance from a horizontal line and a focal point, something like this. Imagine if you want to find different points in the x and y axis that they have the same distance from the point and from this line. So for example, one of them would be just the midpoint of, from this point to this line, the midpoint is just right here, let's say. Another point that will have the same distance, for example, this distance up to here, and then the same distance up to here. That means this distance is the same as this distance. So that's the next point. And so on, all the points, if we connect them together, we get exactly this shape. So all these points are located near this focal point, the red point, the fixed point, let's call it F, and this horizontal line, let's call it H. So juxtaposition, parabola, there are all these points located near this focal point and near this horizontal line. That's why they nickname it as a parabola. So any point you consider in this graph, in the graph of quadratic equations, if you draw a line to the focal point, that's the same distance as you draw a line to this line, horizontal line. All of the points have that feature. And how to find this horizontal line and how to find the focal point, that's going to be a completely another video. So, to summarize, let's summarize everything we covered in this video. So I'm going to use these shapes. Here, I'm not going to wipe these out. So here's the summary. When A is positive, we have a shape that the mouth is upward the vertex is at the same time the minimum, where A is negative, the vertex is maximum. You may say, what about when A is 0? If A is 0, there is no second degree equation. It turns into a first degree equation. Also, we learned about how to go from the general form, which is ax squared plus bx plus c, how to go from this to the vertex form, which is y equals a times parenthesis x minus h to the power of 2 plus k. How to go from this to the other. And we also learned that the vertex for parabolae is h. The x of it is h, the y of it is k. And if we want to express it with ABC, the x is minus b over 2a, and the k of it is c minus b squared over 4a. So those are the coordinates of the vertex, or the minimum and maximum of the equation, depending on the sign of the a. And also we learned that, so already you know h equals minus b over 2a and k equals c minus b squared over 4a. But also we learned about the relationship of a, b, c to h and k. And we know a is the same, a is a in both equations. B equals minus 2a times h, and c equals a h squared plus k. That's the summary of what we covered. And we know c, the lone number in the general form, is the y-intercept. So the y-intercept is, the x of it is 0 and the y is just c. X-intercept, we find them by using this formula. X equals minus b plus minus square root of b squared minus 4ac over 2a. And for x-intercept, those are the two x's, if there are two. Sometimes there are one and sometimes there are none. And that we can find out by the sign of the determinant, b squared minus 4ac. If it's positive, you have 2 x-intercepts. If it's 0, you have 1 in x-intercepts. And if it's negative, you have no real solution, no x-intercept. Hope you guys enjoyed it. Let me know if you have any questions, comments, or suggestions for new videos.